Okay, so in today's now we're gonna start with our the last module, or which basically comprises of the advanced MapReduce concepts like custom keys, custom values, custom partitioner, custom sorting comparator, grouping comparator, and those are the advanced concepts. And we'll also talk about the joins and the secondary sorting in this module. Now, so we will talk about in this module custom keys, custom values, custom partitioner, how to write custom partitioner, custom sorting, and grouping comparator. Right. And the two important concepts wherein we'll be using these above concepts. Those are reduce side join and the secondary sorting, which will involve all these concepts. Right. So we'll start with the custom keys, custom values, how to write our own custom keys, how to write our own values. And the moment you start working with the custom keys, you have to always see about partitioner, sorting, and grouping. Right. You have to implement your partitioner as well as sorting and grouping comparator as soon as you talk about having the custom keys. Now let us talk about the various phases. What are the various phases of your MapReduce job, if anyone remembers? The various phases of the MapReduce job. So what are the various phases, guys? If you remember, various phases.
Map,
Yeah.
map, partition, shuffle.
Yeah. So you have a map. So on the mapper machine, let us talk about. You have a mapper machine. So on the mapper machine, you have a map phase running. On the same mapper, you have the partitioner running, right? Partitioner on the same mapper, and then a partitioner, and also you have a sorting here. On the network, you have basically have a shuffling. Shuffle is nothing but transferring the mapper output to the decimal machine. Transferring the mapper output to the reducer machine. That's basically a shuffling. Okay, and then you have the reducer. On reducer you have on reducer machine basically, I would say. So you have the sorting again, then grouping, which you know it, and then you have a reduce phase. That is basically reduce method gets called up. So what we are talking about actually modifying all the phases, customizing the entire all the phases of your MapReduce. That's what we are going to talk about in this advanced concepts. Right now, till now we have been working with the, I would say, keys, primitive types. Basically, those are not their box types, which we say primitive types. Why I am referring as a box types? Because those are the starting or the data types which you have to use it, right? For example, if you talk about in Java, if I talk about integer, that's your primitive type, but corresponding box type is integer. I will talk about char. So corresponding box type, you have a string or a character class. You have a long, that's your primitive, but then capital long, it's your box. You have a float, is a primitive, capital float is a box. Box is nothing but you have a class, right? And so similarly, when you talk about Hadoop data types, so it's a text, it's your first, which basically represents your string data type. You have a double writable, you have long writable, you have float writable, you have a lot of data types, boolean writable. You have a lot of data types. Now, also you need to observe something that we have a writable, right? Okay, now that's we'll talk about. So these are the data which you have been using for your writing a MapReduce job. Now, sometimes you might want to have a write your own class, custom class, which is acting as a which will act as your key. That's how we're gonna use it. That's how we're gonna write it. That's we will see in our this topic. Okay. So if you see this, the working with the Hadoop primitive data type does not offer much flexibility over grouping and sorting. To understand this, we have to go a little further back, but I'm not. Let us go step by step, because this slide is very this particular bit we need to understand with respect to secondary sorting. But I will skip this slide for a moment. What I'm going to do here is, okay, this is, so for example, class, if you understand with respect to Java, the class is one data type, right? So here, when you want to write your own custom data types, you need to will have two interfaces. You have basically two interfaces, writable and the writable comparable. Okay, I think I have I the slides are less over here. Okay, so let me just give you an overview. Maybe I'll share new slides for this custom keys and custom values. Custom keys. So there are two interfaces which you have: writable interface and writable comparable interface. There are two interfaces. Writable interface, this is for your implementing custom values, implementing values. So whenever you want to implement your own value class, then you will be implementing this writable interface. Then similarly, writable comparable interface, when you want to implement or implement your keys. So if you want to make a certain class as your key, then you will be using this interface, writable comparable. So then Hadoop will understand, yes, this is my key. Okay, and also point to be noted and observe that here you have a comparable, and also and you know that in MapReduce the keys are sorted, right? The keys are sorted. Keys are sorted. Keys are sorted, not the values. Now, what kind of sorting happens in keys, guys? Lexicographic sorting, right? Lexicographic or dictionary based sorting. That's the sorting happens by default. So in MapReduce, keys are sorted. So that's why you have a comparable here, which basically gives you it it has a method by name compared to which you need to implement and tell the framework how your keys needs to be compared. Because since you are implementing a custom keys, so you need to tell the framework that how you want your keys to be compared. Okay, fine. Now let us what we will do. Having said that, let us we'll start with very baby steps to understand the custom keys and the custom values, and we will go back to our whatcon problem. And the whatcon problem, what was the key? The key was a word in MapReduce. So in your mapper phase, in the mapper phase, the output key, if you remember, is a word, which is basically of type text, and the output value was 1, which is basically int writable. Now we will use the same concept, but instead of passing as a text and an int writable, what we will do, we will have our own class. We will have a class, let's say class by name output key, and this class will have a member variable of type text. So this class will have a member variable of type text, and where we will set our in word. Okay, so let us see that. So what we will do, we will quickly for the word count problem, we will use the custom key and the custom value concept. And while actually doing the code, I'll explain you the three methods which will be coming up, that is read and write. So you need to understand that in Java, okay, let me bring you the important concept that though Hadoop is written in Java, this is a very important thing. Though Hadoop is written in Java, it does not use this Java serialization. Why? You please figure it out that why Hadoop does not use Java serialization. Hadoop uses the serialization and deserialization through the interfaces it has provided. Through those interfaces, that is writable and writable comparable. So through those through these two interfaces, it provides a serialization and deserialization of your key value pairs. Serialization is basically, what do you mean by serialization, guys? Serialization is converting the data into byte arrays and sending over the network. What is deserialization? It's the opposite of your serialization. That is reading the byte array in simplest form and converting into the actual object. So what needs to be important? What important in serialization, deserialization is the way serialization is nothing but writing part, right? Writing that is a way of writing. That is, you're converting the data into byte array and then sending on the network. And deserialization is basically a reading part. That is your how do you read the data. So what you need to understand, that you need to know how you have written the data, then only you can read it, right? What I'm trying to say, that you can read the data only when you know how you have written the data, right? And that's where the order of reading and writing always matter. Order of reading or order of writing and reading. When I say order of writing, that is serialization, and reading, that is your deserialization, matters. Okay, so let me just write so as I've explained you, I'm gonna rewrite my what con problem in such a way that in the mapper phase I'll be using custom keys and the custom value instead of text and writable. And how am you gonna use it? Just I'll show you right now. So here, word count mapper, it is taking output key as a text, output value is int. Instead of that, I'm gonna use my own custom key. So instead of text, I'll be using my custom key. Instead of intratable, I'll be using my custom value, which will be incorporating one. The every logic remains the same. Only the way I am rewriting it will be different. Instead of text and intratable, I'll be using my um, what do you say, custom key. If you just click on F3, and if the sources are available, if you click on F3, if you see that it is implementing writable comparable. Can you see that? It is implementing the writable comparable method interface, the two interfaces which I've just told you. Okay, now this writable comparable, and it's also binary comparable is basically, let me just go back here, let me just see. Okay, it's a basically it's like a comparator. It's you have a comparable interface in Java, so it's the same as a writable comparable, right? Binary, I would say it's the same as your comparable interface in Java, writable comparable. And you will see that here you will have your um, read write method, public abstract class. Let me just see here. Yeah, you have command O, read fields and write methods. You can see that you have a read fields methods are there. You can also say write methods are also there. Fine. Now how we'll write our custom keys? Now you'll see that. Okay, so now I will going to have my custom key. Let me name the class as a custom key itself. But in order for the Hadoop to recognize that it is my that it is my key class, I have to implement the interface. Implements implements the writable comparable interface, and the generate takes up your custom your class name itself. Now you see it's a red mark over here. That means it is asking you to implement the methods which are given in the interface. So you say add unimplemented methods, and if you see this, these are the three methods. It's a key. Remember, I have implemented it writable comparable, which means that this class is gonna act my key. So this class is acting as my key, will act as my key. Can act only as key, that is the most important thing. Can act only as key, I would say. And you need to provide this, so you have to overwrite, you have to provide the implementation of these three methods. If you see that compare to method is there, wherein you need to provide, since this is your custom key, since this is going to act as your custom key, you need to tell the MapReduce framework how you want to compare, how you want to compare your keys during your sorting phase. Because comparison will be done only during the sorting, right? So how your keys needs to be compared during your during sorting phase. So that what you need to do. If you do zero, no comparison will be done. If you just written as is, no comparison is done. Now here write. So this is your serialize method. So this is your serialize method. How you will write the data, how you wish to write the, how you wish to write the data in, and it's basically data is nothing but member variables of class. Whatever member variables of a class, that's your data, and how you wish to write the data is basically how you wish to write your member variables, and how you wish to read the data. That's your basic deserialization. Basically, when I see how you wish to read the data, how you wish to read your member variables, and what you need to make sure always that that uh, the way you read and write the data, the order of writing and reading data must always be the same. That you need to keep in mind. Now, custom key is a class going to act as my key. It will have one data point, that is your private text word, and I will have my constructor uh, public custom key. Okay, so you can actually say word equal to new text. Yeah. So you have initialized your member variable, and you might want to provide a setter method, whatever method you want. You might want to provide a setter method, let's say. So public setter and getter. I can select my word, right click on it, say go to source and say generate getters and setters, it will automatically generate the getter and the setters. Yeah, so I have set word. Generally I might want to take as my string, because I'll be passing the string from the outside, and this dot word dot I will say set. So this looks good. So this method I will be calling from outside. And how you, okay, now here, now this is important. How you want to write your member variables. There is only one member variables, so not a problem. There is only one member variable, so I can say this dot, okay, out dot. So what I can do, I can first write my word, right? So I am actually calling my word, and my word is also text writable comparable, so it has a write method in it, and I'm passing the same out. Similarly, I want to read this dot word dot read fields in. I'm actually calling the same methods which is present, because word is also a writable comparable. So I'm first writing my, I'm this, there is no order which I have to maintain, because there is only one member variable, and I have to compare it. So I can always compare this dot get word, my word dot compare to o dot get word. So I'm comparing whatever comparison. I'm just worried about the comparison of my text. So if you go inside text class, and if you say search for your command, you compare. So actually they're comparing in the byte. Don't worry about the byte one. So here it is actually comparing in bytes, which is much more faster. But I am doing the comparison in my. So when you compare, so I'll explain that why they have comparison in the bytes and all to improve the performance. But here you don't have to worry. What I'm trying to do here is just relying on the comparison of my text class. So whatever this guy provides me the comparison method, I am just relying on that. I'm using that comparison method. So I'm actually okay with that. Okay, now this is your key class. That's it. Now what you need to do now is to, for example, I'll just go with my I'll have just my mapper class. I'm going to say just have a custom key class. So what count mapper. Now instead of here text, I will be passing my custom key, and you see that here. That's it. So I am using my custom key instead of my text, and I will create a member variable here of my custom key, private custom key output key equal to new custom key, and output key dot set word, and I'll be passing my output key here instead of new text. See this, now this is straightforward. So you have custom key, everything remains the same, but what I'm doing here is the word, whatever the word is coming here, I am actually putting into my output key as my member variable. I have created my output key, and then I will be actually setting up here. If you see, I am actually setting it up in my that word, whatever the word is coming from the outside, I am setting into my word, that is my text, and passing it, and passing this output key over here. So it's that simple, right? Now let me also write a custom value here, wherein int writable is 1, but int writable is always 1, if you see that here, right? So I will make a constant 1. So let me just make a class by name 1. Let me just say 1. That means basically represents I'll say 1. That's my class. Interfaces would be, the interfaces I will be using is a writable interface, because that is where it is going to act as my value class. So as I've just told you that custom key, so this is going to act only as key because you are implementing the writable interface, and this class I want to have your writable interface, so this class can act only as value. This class act only as a value, and point here you to need to note there is no compare to method. The reason it is not compare to method is there because values are not sorted, right? Sorting happens only on keys, so that's why there is no compare to method. But it does have the read and write field because it has to be, because value is a data point, so it has to be serialized and deserialized. So it has the same two methods which you have, which I have just explained you. And what I will do, I will have private intratable 1 equal to new intratable of 1. That's it. I can have this as right. Okay. If you're not comfortable with this, I can have a constructor public, and right. So you have in new intratable 1. That's it. It's a constant. It's a constant 1, and I can go here and I can remove it as a 1, right? And I can just say private 1 1 is equal to new 1, which says that it is always 1, and I can use my 1 over here. So you can see that I have made use of my custom key and the custom value. It's a very basic problem. It's a very basic problem. First step to understand the custom keys. Then I will explain you that moment you use the custom keys, you have to have the partitioner needs to be defined. I'll give you a couple of problem statements, but I want you to concentrate on a very basic thing here. Now, what we will do, we will use a test, right? We know how to test. Okay. So how you want to test it? So we will use the um, custom key word count testing. Let's say I will be using this custom, but I'll be creating a new class, and I will rename this class as a custom key value custom kv word count testing. So we know how to test our uh, uh, mapper functionality and reducer functionality through through our MRUit framework. So you have a map driver, okay, but map driver is a long writable text, and it will be a what? Custom key, right? Just now I have written my custom key, and this would be 1. The reduce driver remains the same. I'm not changing the reduce driver logic here, but reduce will receive custom key here. Okay, I have made a, we have to understand this. Okay, let me go back here. Okay, let me just make it everything working here. So once you have changed the output value from your mapper, it goes to reducer, right? So reducer will also has to be changed. This thing, custom key and the custom values, it has to be changed. So I will make it as a custom key, and this will be 1. And once it has changed, the signature of the method will be changed. I have to make this. Now it is fine. Now when you iterate over the ones, so intritable 1, but it is no more of intritable 1, it is of 1, right? So 1 you are iterating, but then val, so you will say val dot, okay, you don't have anything inside the val which will give you the 1. So val dot get 1. Okay, I have not actually implemented this. Let me implement this also first. I'm very sorry I have gone like that. So you have done this, then you might have to come back here and then say this dot 1 dot same thing dot right. There is no order because there is only one member variable, so that does not really matter. I can have a member variable here, public get val, sorry, public integer get. So I will say this dot one dot get. So basically what I'm trying to do here is just returning whatever the value of my iterable, which is always 1. Return this dot one dot get, and I can go to my reducer class. I will just say val dot get, and once you have done that summation, so key, this is your key, custom key. So I'll say key dot get word. That's your actual word, and new iterable of sum, new long iterable of sum, whatever. So we will not going to change the output key from my mapper, from my reducer. So it will remain the same. Now we'll go back here and start writing our test cases. So here the map driver, as I've just told you, long writable text. That's your input key, input value. And now output key and output value I'm going to change. Output key will no more be a text, it will be a custom key. And the output value will be 1. Okay. Similarly here, it will be reducer driver, it will be custom key. And this would be 1. And everything remains the same. Reduce driver, map driver, if you want to test it, so this will be custom key, this is, and this will be 1. So you have defined this, then this is your fine. So this is your input key, input value, and then this is output key, output value from mapper. The same will become the input key, input value to the reducer, so we are not defining it. And this is output key and the output value from your reducer. Now setup method, new map driver of new word count mapper. This is not the one which we wanted. We wanted the word count mapper from different package. I think we should give, it's a high time that we should give new mapper name. So I'll say custom key value. I'll just say what custom rename. I'll just use custom word here in the front. I will also use custom word here. But why do we want to have a word count driver here? Because I think we remember we have only one driver class, so we don't require, we really don't require it. Delete it, because we'll be using, if you remember, we'll be using what? We will be using the XML file word count mapper. So this refactor, I will just add a custom word count mapper. Spelling, I'm refactor, rename, and this class as was custom word count reducer to custom. Okay, so this is fine. So I have appropriate classes name, key, and the value. So this will be new custom word count mapper. This will be new custom word count reducer. New map reduce driver would be new custom word count mapper, new custom word count driver. Okay, so we'll see the test cases first. So what we are going to test here, um, so map driver with input long writable new text, hello, how are you, give your expected output. Okay, this is my, okay, this is just testing the mapper, right? So in the map I will be, what I'll be doing, what do we do here is custom. So what we will do, it's a custom key value pair, right? So we will be emitting 1 is equal to new 1, right? Okay, new pair of text. It will not be a text, it will be a custom key. It will be 1. And this will be new custom key. Okay, I don't have okay, what do I do now is new custom key, right? So I should actually, I'll provide one more constructor here, which takes up the word, which public, I mean to say public custom key string what, just for testing purpose. New text of word. Now I can go back here and new custom key. Now pair of, so it has to be also changed custom key. So if you have, I think I'm just doing a cut copy paste, so you should be comfortable because we have previously done this for our. So it's basically expects a list of pair of text entry tables, list of into IKVs. So now you add it up. So it's a list of pair of custom key. If you have any doubt, just let me know. And now if I run this test, so it should be proper. It should be fine. Run as unit test, and this test should pass. Okay, missing expected output. Okay, let me just, so this test says that um, it is missing expected output, custom key. This is a custom key, com training custom key at position 2 got, what is it, what do you call it, this very, oh, where is it? Let me first delete all these test cases, or I'm getting confused here. Okay, so when we pass, so new text of hello, how are you? So hello, so we will be emitting new custom key of hello and 1. Custom key of how 1, custom r, custom u. So these are, and in our custom word count mapper, we are actually custom key. Okay, the problem here is, okay, let me, okay, so it should come up here. Debug as, is it checking the address? So it should ideally give me the value why it is checking. So if you see here F6, my output key, it is word, word dot length hello. I am setting my output key, and the value is 1. So actually I am emitting all the words. But then, so here it says that custom key equals object is not being even test may fail. Custom key hash code, custom key two strings, and these are things are not written, so it may fail. So let us do one thing. We'll say right click, run as, source, and generate hash code and equals. And similarly, I will write my hash source generates hash code and equals for both of them, for both the classes, and let me run it once again. So this time it has passed. The reason it was not able to compare it. Now this is so whatever we have written, it is fine. Now let us go to another test case. Test word count mapper 2. So that what was that? Test word count mapper 2. Similarly, what I'm trying to say that you might want to write the test cases like this. And okay, this is the same thing. We have already done this, so I don't think so. We have to. Only thing here is that hello, how are you? Everything remains the same. I just need to cut, copy, paste this. I just need to cut, copy, paste this. That's it. I just want to test these things that whether it is working properly or not. So this should also pass. I'll right click on my test case, run as June test case. So it should pass. So similarly, you can write all the test cases, right? So this is the very basic thing that you should know, how to make use of custom keys and the custom values. Okay. Now, what I want to do today, what I want you to give the exercise is that I think I have showed the employee data set. Right now, in this employee data set, in last class I think I have showed you employee data set. Let me also pick up this employee data set. This is employee tables.csv file. Now, if you see in the employee table CSV file, you have a first name. Consider the column A as your first name and column B as your last name. Just for the time being, I want you to what I want you to do: make a custom key of a first name and the last name, and the value as your last name. Let's say so. Column A is your first name. So this is your first name. This is your last name. Okay, this column. This is your first name and the last name. Now, so what I want you to do quick for tomorrow's assignment, which I want you to complete this, I mean to say, we will do an exercise that I want you to have a custom key class name, a custom key class by name person. Let's say, so we will have a class by name person, wherein there will be two member variables which represents first name, which is of type text, and the last name, which is of type text. So there will be two member variables. Okay, and the value from a MapReduce job will be of type, that's your output key from your mapper will be of type text, and this could be your last name. Which means if that is the if you take up if I take up the first entry, then my output key value from the mapper, what I want now, so my mapper, so I will have a person mapper which will emit the mapper will emit the output key of type person, which is your key class, custom key class, and output value will be text. So key class is a combination of your first name and last name. and the value will be text and is basically a last name. That's the second column. Okay, and what you need to do, you just need to have one reducer as of now. Let's have one reducer only right now. And what you need to do is sort the output in such a way that your first names or your last names are sorted. Okay, sort the output in such a way that last names are sorted. You need to do this and have only one reducer. So this could this so this is an assignment. Okay. So once you do this, you will get a fair idea at how actually you want to do it. I will give you next small problem statements like we'll talk about more in details about the partitioner and the sorting and grouping comparator tomorrow. Okay, in the next class. So thanks for today, and let's join tomorrow.